In this video we'll look at how to calculate the volume of a cone, and we have the formula for that here. Volume of a cone is 1/3 pi r squared h. So the volume of a cone is 1/3 of the volume of a cylinder formula. In the first example here, we're asked to calculate the volume of the cone in litres. Give your answer to two significant figures. Now there's a couple of things going on in this question. First of all, it's been asking us to work it out in litres. So we do need to know our conversions between cubic centimetres, millilitres, litres and things like that. We'll initially, obviously, because this is centimetres, the first thing we're going to calculate is how to find the volume in cubic centimetres, and then we can convert those cubic centimetres into litres. The other thing is we need to round our answer to two significant figures. So let's start off by writing down the formula here. So volume is 1/3 pi r squared h, and start subbing into that. So it's 1/3 multiplied by pi multiplied by r squared. Now r, remember, is the radius, so I need to check that number up here is what I've actually been given. Remember, the radius is from the centre of the circle to anywhere on the outside. So the radius is not this 6 here, that 6 is the diameter. So I'm looking for the length from there to there, the radius, which would be half of the diameter. So up at the side here, I'm going to put diameter was 6, so radius must be half of that, 3. And then I can put that in as 3 squared times h for height. Now, the height of a cone will always be the kind of centre of the circle measured straight up to the point at the top or bottom there, and that is going to be, in this case, obviously 8. So 8 goes in there. When you're typing this into your calculator, some of your calculators will have a fraction button, so you can make the 1/3 look like that. But a quicker way to do it is just write or type 1 divided by 3 times pi times 3 squared times 8, and that gives us 75.398, and that is in cubic centimetres. Now we'll come back to the question here, because it asks us to do a couple of things. It asks for the volume of the cone in litres. Obviously that's not litres, so we need to change that. Now the important conversion rate, again we need to know this off by heart, is that 1 litre is equal to 1,000 cubic centimetres. So if I want to turn this number here into litres, obviously that's less than a litre because it's only 75 cubic centimetres. I need to divide this number by 1,000. So I'm going to do that just now. Divide by 1,000 means moving the decimal point 3 spaces to the left. So it's going to be 0.075398 litres. The next thing the question asks us to do is to give our answer to two significant figures. Now, significant figures, remember, they start from the first non-zero digit. So we don't count this or this because they are starting zeros. We start counting significant figures from the 7, so that's first and second significant figure. So I'm going to put a little marker in here, just lightly, a dotted line, so it doesn't get mistaken for a 1. And I'm going to look at the number directly after that, which is 3. Now that 3 tells me to round down the way, so very quickly that's going to become 0.075, and that's litres, and that's now both in litres and to two significant figures. Now that question we've just done is a normal standard cone question. This one is slightly different because sometimes we are going to get questions like this in a non-calculator paper. If we get it in a non-calculator paper, the question will often say using pi equals 3.14, or occasionally, as you'll see in the next example, leaving your answer in terms of pi, in other words, leaving the pi symbol in your answer. The important thing about this question is to just start it as you normally would. So let's start it off with the formula. Volume equals 1/3 pi r squared h, and start to sub in. So that's 1/3 multiplied by pi multiplied by, again, when we get to radius or diameter in one of these questions, just check that's radius I need, and that 3 is definitely the radius from the centre to the outside. So that's going to be a 3 squared goes in there, and the height of this cone is 10. Now, when you get to this stage of a question, this is usually where you would reach for your calculator. So a couple of things going to happen. One, we're asked to use pi equals 3.14, so you might be tempted at this stage to write this out again and just swap that out. 3.14 times 3 squared times 10. The next thing is, these questions require you to do the calculations in a certain order. Now, you can do them in any order, however, there's a way of doing these which makes it easier. So, to start off with, this third here which of these numbers would be easiest to find a third of? Now, a third of 10 is going to leave you with decimals. A third of 3.14, if you actually tried to type that into a calculator just to see what it looks like, it's not going to come out very nice. It's going to be a lot of decimals involved in that as well. But 3 squared is 9. So let's just do these step by step. 1/3 times 3.14 times 9 times 10. Now, if I look at that, that's the easy number to find a third of, this 9. So a third of 9, effectively that's what I'm going to do at the moment. I'm just going to concentrate on 1/3 times 9, which is a third of 9, which comes out to be just 3. So now it's 3 times 3.14 times 10. And again, looking at the calculations here, again, I've got this decimal here and I've got this times 10. So thinking about this, if I multiply this here first, then I can leave that 3 where it is, because that leaves me a nice single digit to multiply by, and that 3.14 multiplied by 10, so here what I'm just focusing on is this part here, that 3.14 multiplied by 10 is going to give me 31.4, and then what I've left myself with is a nice kind of single digit multiplied by this, which I don't want to try and do it in my head, although you maybe could do this in your head. You probably want to write it out at the side, 31.4 multiplied by 3, and that 3 4s are 12. We'll put our decimal point in. 3 1s are 3, plus the one I carried is 4, and 3 times 3 is 9, so 94.2. So that is my final answer. So really what you're trying to do with these questions is just think about, remember cubic centimetres for volume here, just think about when you get to this stage, what order makes this question easier? What order to do these calculations in makes it easier? To give you an example of where things could go wrong here, say for instance I decided at this stage to multiply the 3 and the 10 together, because that's quite an easy calculation to do. Then I've left myself with 30 times 3.14, which just feels like it's a little bit harder than doing 3 times 3.14, because obviously 3 times something is just a nice single digit calculation there. The other type of non-calculator question you can be asked, so rather than them saying use pi equals 3.14 and get an answer as a decimal like you did in the previous example, occasionally they can say show that the volume can be given by 384 pi, in other words, leaving the pi in your answer. So let's start off this question in the same way. We're looking for the volume of a cone, so the very first step is volume equals 1/3 pi r squared h. And we're just going to start to substitute into that as normal. So 1/3 times pi times, again, check when you've got radius or diameter, that r there is radius, and the radius is from the centre to the outside. So 12 is the radius, so I can just put that straight in. 12 squared multiplied by 8. Now, this, again, is where you would normally reach for your calculator, but this is in a non-calculator question or a non-calculator paper, so we can't do that. Now, the question says, show the answer is 384 pi. So this pi, I still want that to be there at the end of the question. So what I'm actually trying to calculate is I'm just trying to work out what this 1/3 times 12 squared times 8 is going to give me. So again, like the previous example, the order in which I try and do these calculations is important. So the first thing I'm going to do is I'm going to square that 12. So it's 1/3 times pi times 144 times 8. And again, looking at this third here, which is easier to find a third of? Now, we know 3 doesn't go into 8 without leaving, a remainder. And if we try and divide 8 by 3, we're going to end up with a lot of decimal places in our answer. But 3 does go into 144 because, well, 3 goes into 12. So let's do 144 and divide that by 3 to find a third of 144. So effectively what I am doing at this stage is I'm just doing this calculation here, a third times 144. And if I start to do that, 3 goes into 1, 0 times carry the 1. 3 goes into 14, 4 times carry the 2, or remainder 2. And 3 goes into 24, 8 times. So that 1/3 times 144 is 48. So now we have 48 in place of those two green parts times 8 times pi. Okay, so this comes to 48, and then we're left with the 8 and the pi still here. Now I'm hoping that when I do 48 times 8 next, that's what I'm going to get. So let's try that. 48 multiplied by 8. 8 8s are 64, so 4 carry the 6. and 8 fours are 32, plus the 6 I carried is 38, which gives me that 384. So 384, and then that's 384, but we're multiplying that by pi, so pi goes at the end. And that's what we've been asked to do in the question. We're asked to show the volume of the cone is given as 384 pi, which is what we have here. Because it's centimetres though, I would probably want to add in cubic centimetres for my volume there.